So in this question, we have a baseball thrown 15 meters per second west. 5.6 seconds later, it's moving 21 meters per second east. So you can picture the ball being thrown one way and then someone else is throwing it the other way. Just on average, you want to calculate what that acceleration was. If it started with 15 west and ended up 21 east. Because there is a direction change, it's a greater acceleration than you might think otherwise. If you just subtract 21 and 15 as change in velocity, you just get 6. Well, the velocity didn't change by just 6. Because it changed direction, the velocity ends up changing by 36. I'll show you how the math gives you that. So, first step, again, what's in purple here is usually what you're thinking about, what you're asking yourself when we solve these questions. Reread it, set up the coordinate system. Okay, so everything east is going to be positive, everything west is negative. Go through it again and start writing down what I know, what I want to know, and make everything relative to the positive direction. So anything west is going to be written down as negative. Very important step, especially moving forward as we start building into more difficult questions with more variables in them. First thing I get is baseball is thrown 15 meters per second west. So that's going to be initial velocity. That's how fast it's moving at the start. It'll be negative 15 meters per second relative to the positive direction, so east. 5.6 seconds later, so that's my time. Time is a scalar, no negative or positive. Well, it's always positive, I should say, but no direction. You can't go 5.6 seconds west. You can move that way with velocity, but time doesn't do that. And the last one, final velocity that we're given, is 21 meters per second east. So it remains positive. So any variable that's a vector, so when you're looking in your handbook under a formula and you have a variable with this arrow on top of it, the direction that's in brackets always has to be the same for every one of them in a problem, or we can't do the calculation. We can't do it. And we're asked to find acceleration. So when we calculate acceleration, it'll be relative to east. So we check for a formula. Oh, we're doing acceleration just like yesterday. So the formula hasn't changed. A little bit of the mathematics has changed, but the formula hasn't changed. A equals change in velocity, final minus initial, divided by time. Put the values in and solve the equation. Values, A equals final velocity, 21, minus initial velocity, negative 15, over 5.6. Substituting, replacing your variables with your number in brackets is just a nice little step so you can clearly separate negative signs, or what's adding with what, what's multiplying with what. This is where little mistakes happen right there. If you forget to change the direction from 15 to negative 15, then this is where your math kind of gets messed up. And you may not notice that the answer is incorrect. So it's going to end up being 21 plus 15. When you subtract the negative, you add the opposite. So let's just finish working it out. Acceleration is going to be 36, and that's where the 36 comes from what I said before. 36 meters per second is the change in velocity. It was going west, ended up going east, so the change has to be positive. It has to end up going east for the change in velocity, and that works out to be around 6.4. Don't forget your units in the end, meters per second squared. It's going to work out relative to east because we set it up that way. And we're done. Double check that it makes sense conceptually. Now that's always maybe easier said than done. The acceleration being eastward, does that make sense? It was initially going west. If you just picture this ball moving in one straight line, no one's throwing it, it's moving west, but then it starts to slow down. It's like you're throwing it against the wind. The wind is going to stop it and then make it travel east again. So maybe a baseball isn't a good example to picture that because it's very heavy, but something like a piece of paper, if you roll that up into a ball, throw it into the wind, it's going to come back at your face. Right? So it's like the wind's blowing east and it's making it accelerate 6.4. So that kind of makes sense. All right.